Hi, so this is going to be a quick run through of how to find the nth term of a quadratic sequence. Okay, so to start with, no matter what sequence you're looking at, even if it's a linear sequence, you want to find out the difference between the different terms in the sequence. To get from 6 to 11, you want to add 5. To get from 11 to 18, you want to add 7. To get from 18 to 27, we want to add 9. 27 to 38, add 11. And 38 to 51 is going to be plus 13. Because all of these numbers are different, this tells us that it's not a linear sequence, because a linear sequence will go up in the same amount each time. So next step would be to find the difference of these differences. So do the same thing, but a row below. So this time, how do you get from 5 to 7? Add 2. 7 to 9, add 2. 9 to 11, add 2. 11 to 13, add 2. So when you're dealing with quadratic sequences, which you can see it is at this point, because the difference of the differences are all the same. So the general form will be an squared plus bn plus c. And the value of the difference of the differences, so 2 in this case, will give us an indication of what the coefficient of n squared is going to be. In this case, just the coefficient of n squared is a. So half of the difference of the differences will always be the coefficient of n squared. In this case, half of 2, so 1. So the start of our nth term will be n squared. Okay, so the next step would be to compare n squared, so what we've got in the sequence so far, to the final sequence. This will allow us to work out the bn plus c part, so the linear part that we need to add on. So in the first row, I'm going to just write n squared. So when n is 1, the first term is 1, n is 2, be 4, 3, 9. So it's just going to be the square numbers. So we get 16, 25, and 36. And then I'm going to write the sequence that we want as well. So the one we've been given. So 6, 11, 18, 27, 38, and 51. The final row is going to tell us how to get from what we've got so far to what we want. So how do we get from n squared to the original sequence? Okay, so the difference. So from 1 to 6, plus 5. From 4 to 11, we add 7. From 9 to 18, we add 9. 16 to 27, we add 11. 25 to 38, we add 13. And 36 to 51, we add 15. So the nth term of this bottom sequence, so 5, 7, 9, 11, 13, and 15, is going to be the linear part of the sequence that we'll add on, so the bn plus c part. Okay, so we can see they're going up in 2s, so we'll start with 2n. So 2n is just the 2 times table, and as we can see, everything is just 3 more than the 2 times table. Put that there. And we can see this, you don't have to do this part, but just to show, we put the sequence 2n at the bottom, we get 2, 4, 6, 8, 10, 12. So to get from this bottom row to the corresponding number on the next row up, you're going to just add 3. So we know that is the linear part. So we just add this on to the end. 3. And that is the final nth term for this quadratic sequence. So at this stage, it's always a good idea to make sure that our nth term is correct. So what I'm going to do is pick one of the terms from the original sequence. I'm going to pick 18. And I'm going to try and obtain it using the nth term that we've created. So 18, that is the third term here. So all I need to do is substitute 3 in as n. So let n equal 3. So we're going to get 3 squared plus 2 times 3 plus 3, which is 9 plus 6 plus 3, which is 18, as we would expect. So yeah. So that's it for that question.